If you are considering building an airplane and maybe thought of installing a custom engine, you're going to want to stick around for this entire episode as Casey Cooper walks us through his custom legacy Sonex and how he went about installing a lightweight Rotax into his airplane. Oshkosh 2023 out here at the ultralight field, and I met this gentleman here last year during the 1 week wonder. Casey Cooper, introduce yourself and where you're from real quick.
Casey Cooper. I'm from Tucson, Arizona, and that's where we build and maintain and work on light sport aircraft.
Awesome. What's the name of your company out there?
Arizona Ultralight Aviation.
So in his day job, obviously he works on aircraft, and then his evening or hobby job, or his hobby, he works on aircraft, and he built this Sonex behind us, and we're going to go all over that in a minute. He built a great example of a Sonex, custom paint job, custom cowling and engine, but the reason I'm pulling Casey aside here to talk to him today is the fact that he has his own firewall forward that he developed for the Rotax 912 ULS, and that just got me really excited. You did a great job. So let's dive right into the details of the engine and specs and performance, and then we'll crawl around the airplane and talk about the aesthetics. Okay, so first up, why did you decide to use the Rotax in this build?
Well, I've flown Sonexes and stuff before, and we flew Xenoses, Sonexes, YXs, and I didn't want a Volkswagen, I didn't want a Jabiru. I wanted to do something different, and I had seen that they had done some Rotaxes in Australia and Europe, and I hadn't seen one completed here yet. I've seen people do some work, but I haven't seen one fly, so that's what I wanted. That's what I'm used to. The Rotax has a great product, so
that drove the mission. And then how did you acquire both the airframe and then the engine in the process?
Well, the airframe, I was looking at the time, and I was looking at a few different aircraft, but this one was in Minnesota, and it was a unfinished kit. Still had a lot of work to do on it. It had an Aero V 80 horse on it, and I brought the kit home, sold the engine, and then we had a 912 sitting in our storage that had come off of a wrecked airplane, and that was the opportunity to say, people don't really like to buy an engine that's been involved in an accident, so I'll take it. So let's use it. So that became my engine for the airplane.
Okay. And describe it to people here real quick. Knowing that this had a history to it, you didn't just bolt it onto your airplane. What did you do to making sure it was verified it was all good?
Well, the engine, I work on the Rotaxes all day long, and it's just very rare that you have to dive into a Rotax past the case. It's very rare. And I have good friends at South Mississippi Light Aircraft, Ronnie and Morris, and I took the engine, sent it to them. I'd much rather have them go through it because they're like the best in the country. So Ronnie took it apart, checked everything out, new seals, knew everything. In the accident, I'm sure it had a prop strike, everything like that. Everything was fine. Ronnie put it back together, put it in a crate, sent it back to me, and I started mocking stuff up. It was an interesting process because with a bed mount, you kind of have to, figure out where you're going to put your radiators and where you're going to hang them. It's the same thing with the ring mount, but a bed mount imposes its own set of issues. But it's just like that with any airplane. You have to work around everything, get it just right how you want it. So
let's get into the details of the build in just a second. How about we share with everybody the performance numbers? I think, like you said, other people have done this in other countries around the world, but this is one of the first, if not the first, customer installation of a Rotax, right? So a Volkswagen is roughly, I think they call it an 85, but in reality I think it's like a 72. This is a true 100 horsepower and a geared 100 horsepower. So share with everybody, what are you seeing for takeoff performance? What are you seeing for cruise? And what are you seeing for like wide open?
Well, that varies a lot, especially where I'm from, because in Tucson, it'll get to freezing in the wintertime, but then also right now at home it's 110, 115. So the air works against you. And I'm based at 2,100 feet. And at that altitude, just on a normal day at my place, if it's like 80 degrees out, our airstrip is about 1,600 feet long. We have an intersection in the center at 800 feet. I easily take off and use only about a quarter of it to maybe 2/3 of that distance, so a 500-foot takeoff, 500-foot landing. I'm always landing before the intersection. No problem. This plane still, you can rotate it at about 40 miles an hour with full flaps, 30 degrees. A lot of people don't take off with 30 degrees because you can't overcome the drag curve with it. But this thing has so much torque and power, you just put in the full 30 degrees, don't think about it. But still, you can rotate at 40, and then you can get into ground effect, get the flaps out of there, and with those conditions, I can easily see 1,500 feet a minute climb.
1,500 feet per minute.
Easily, just with me in there. I just crank it on up and get out, and then.
Is that sustained, or is that just the initial pull?
Oh no, that's sustained. Sustained long enough. Once I get to about 4,000 feet, then you start tapering off pretty good. But the wings are so small, you got to make them work for you. So the higher you climb, the less they want to work.
What does the deck angle look like? That is it pretty severe, or?
It's pretty steep. Yeah, I can't see over the nose at all. So, but yeah, it just keeps clawing on up there. So. But that's just where I am at sea level. I can probably do a whole lot better at 70 degrees. I know in the winter time at home when it's about 50 some degrees out, I can crank that thing up and I get 2,000 feet a minute. And I can't sustain that for a long time, but it's just like I can get to pattern altitude in a matter of half a minute.
Yeah, that's incredible, and for especially for a full canopy aircraft, you want to try to get up to the cooler air as fast as possible. So in a matter of a minute or two, you're in the air conditioning.
Oh yeah, absolutely. So, and once I'm up there, I can still. It's nice because I can, like even coming in here yesterday, I comfortably cruise at 90 miles an hour, following everybody in here. No temperature problems, no issues, and even on the way here from Tucson, I was flying in North Dakota, cooking on along at 150 miles an hour at 5,300 RPM. So it's just and you can still cruise out at 5,500 Rotax all day long, no problem. And that I'm getting like 160, 165-ish depending on the temperature and altitude. That all comes into play.
That's an incredible cruise for 100 horsepower.
Well, like with the Jabiru, the 3,300, they produce very similar numbers in speed. In my opinion, after having flown several Jabirus in a Sonex, they can't touch me in takeoff and climb, but they definitely can outrun me in cruise by probably about 5 miles an hour. Okay. But they're spinning much smaller prop, much higher RPM. That thing's way dialed in there, and they have 20 more horsepower. So you definitely get that upper end with that engine.
So, and except 155, 160 miles an hour. And what are you all in? Obviously, this is a Rotax, so they don't recommend you running 100% power longer than like 5 minutes. But if you were to do a quick little run, what can you get? What do you see?
Well, you're pretty much at its peak drag curve at 150 some miles an hour anyways. So any extra power you're giving it, you're not really picking up much on the airspeed indicator. But at 5,800 RPM, that thing will pretty much top out around 170, 175. You can't get much more. It's just you're freaking going for it.
and the aircraft, the design itself, the VNE is right around 199 or something like that.
Yep, yeah, 198 I think, but yeah, 200 miles an hour, whatever you want to call it. So, yep, yeah, and it's a great sleek design. It's a lifting fuselage design, and depending on how you do it, if you do your best to take care of things that impose drag and all those things, you can really gain a lot back by just taking care in your build and trying to pay attention to that.
We are partnering with great companies like Dynon Avionics at Dynon.com, Airtech Coatings at AirTechCoatings.com, Clemens Insurance at ClemensInsurance.net, South Mississippi Light Aircraft at FlySMLA.com, Foxtrot 95, Calhoun County Airport at FlyFoxtrot95.com, Edge Performance at EdgePerformance.no. Take a moment to go visit their websites at the links found below in the description of this video. And visit our website at ExperimentalAircraftChannel.com for events, our video library arranged in easy-to-find playlists on specific topics, and so much more.
All right, so stepping over to the cowling, we'll kind of work our way into the aircraft, being it's cowled at the moment. Maybe I can convince Casey to remove a few screws and see the engine here. But let's talk about the cowling design here, because that's a major thing with any aircraft is cooling, especially when you're doing a new engine installation, and he did a custom cowling. So what was the process that you used after having the engine mounted to create the cowling? Some people bag it and foam it and then carve it, and then other people start. How did you go about that?
Well, I actually had 2 cowl designs. The first one was awful. I had the exhaust hanging out the bottom. I had my radiator out in the open. I just didn't know what to expect. I flew it like that for a year to really kind of grasp what I needed to get done. And so I bought this cowl from Sonex. It's a horizontal split. I got rid of the vertical split. And it started out as a basic cowling, but I ended up gluing on a bunch of garage door foam, the Pink Panther foam, and you sit there with the orbital, sand it out, get it shaped. Once you're happy with your shape, lay up your masking tape, lay up your fiberglass, get your blisters, pull the molds, apply, graft in the blisters. But before that comes, I had to pick out my spinner. I had to figure out my radiator placement. I had to figure out a lot of that, the small logistics of that first. So it not only had I done the firewall forward once, I redid it again. So I've almost done it twice or 3 times.
Did you start off kind of like penciling this on a napkin as far as the design of inlets and all that kind of stuff, or did you just kind of molded it as you shaped it?
I molded it as I shaped it. Like this spinner, I ordered it. It's a full carbon fiber spinner, and I used a wood plug on the backside on my prop flange. So that kind of gave me an area where I could mold my foam to. And once like these inlets for the air, I actually closed them off with tape, and then I just started drawing on the cowling with Sharpie. Then I'd go back and wipe it off, and I'd draw some more, wipe it off, draw some more. And that's eventually what I came up with. Just a little bit different shapes than normal. You always see the holes, or you see the D's, or you see, it's just different. Make something different.
It is. It has a very modern look, and almost kind of like ties into like some type of automotive styling a little.
Yeah. It's. I've heard that before. People are like, well, that's kind of like looks like something Lexus would do, or something like that. I mean, don't compare me to Lexus, but it's just different, angular and things of that nature. So
a lot of things in aviation, there's a battle between function over form and form over function, and this to me seems like just aesthetically it might be form over function, but talk about how it actually functions and how you did initially versus modifying to make it stay cool.
Well, honestly, it kind of functions too good. And I don't mean that in a conceited type of manner, but it's just like in the wintertime, I can't get the engine up to temperature. It won't get there. It runs too cool. So I had to add an oil thermostat and everything into the system to try and actually bring the temperatures up. And even at home in 110 degree weather, I still only see, so this is older motors, so I still only see about 210 or 220 degrees cylinder head temperature. I'm allotted 300. And I see 210 degrees oil temperature, and it's just right over the edge where I need to have enough heat to boil off any contaminants. So,
did you get that right out of the box in this creation with just a little bit of adjusting with flanging, like rubber flanging and stuff like that, or did you have to cut new holes and new fiberglass to fix it?
Well, no. So this cowling was always how this cowling was when I first did it. I never changed anything after it. I originally had the oil cooler and radiator just hung in the bottom of the engine compartment. In the Rotax, you really don't have to baffle a whole lot to get your cooling done properly. But the air coming into my inlet on the bottom, the air takes the path of least resistance. So you're hoping that it's going to go through your radiator, but that's not always the case. And I was bouncing right off redline all the time for my first few flights, and I said, no, this isn't enough. I have to change something. So at that point, I went ahead and grafted a scoop on the inside, and then I made an aluminum scoop that houses my oil cooler and radiator, kind of like the F1 race cars, a very small inlet, high pressure, large area for the radiators, and a small nozzle at the back to help reduce cooling drag. And once I did that, this induction system for my radiators is a completely closed off compartment from my entire engine bay. So the radiators see no engine compartment heat whatsoever. It's just my inlet at the bottom. And that's how I got my cooling exactly where I needed it. So.
Well, it sounds amazing. Do you think you might be able to showcase some of that and let us see behind the curtain?
We'll see what I could do. We'll see if I have tools. I took all my tools to the hotel. Gotta find some.
If you're building an airplane, then you know. Getting an engine successfully mounted up is a big deal. It's probably the biggest milestone in your adventure of building. And then, to show off your installation to a fellow builder, let's just say you've earned a bit of bragging rights. I have a personal interest in this particular installation and was happy to have interviewed Casey for this episode.
All right, so we've convinced Casey to uncowl, not undress, but at least uncowl, right? So we can see the engine here. Let's talk about engines. What was the process of getting? I've seen things a few different ways. You guys have probably seen Mike Payton, the scrapping, where he got this whole apparatus he built with jacks and to get the engine level. How did you get the engine to the position you needed and then build the engine mount to it, or what process did you use?
Well, Sonex produced the chromoly engine structure and landing gear structure, and they had a attach bar kit. That kit hadn't actually been flight tested. I tested it. We had some problems. I ended up having to re-engineer a system. This system, I didn't hang the engine or do anything. It was just math. Just sat down, did math, wrote it all out on paper. I'm not a CAD guy. Just redesigned it into a bed mount system instead of a rail system, maybe you would call it. Machined them on the lathe, plugged them in, put the engine back in, and that was it. Just math, good old math.
And that's where you got your good thrust line and to match up with the airframe.
Yep, that's it. Yeah, just match the existing structure, put the holes where I needed, measured those holes according to the old attach bars so I knew where the prop flange would be, and just left it alone.
I'm jumping ahead a little bit, but when you did your weight and balance, doing that ended up being spot on. So your CG with this engine weight?
The Rotax is really light. It's a bit lighter than the Jabiru, and it's lighter than the Volkswagen.
It's lighter than the Volkswagen.
Go on the Rotax website, you take the engine and set it on a scale minus your components that obviously vary from aircraft to aircraft, whatever radiators and stuff you want to use and exhaust systems, and the engine itself weighs 125 pounds. So there's not a whole lot there. So this thing, I actually kind of have an aft CG. So like on the way here to Oshkosh, I really just have to shove things underneath the instrument panel, shove things in my seat, and then just put a little bit in the back. So
that's amazing that you have the slightly aft CG on this.
Yeah, and and a slightly aft CG is desirable. By no means is that a bad thing. It's just you don't want it too far aft. So I mean, slightly aft keeps your speeds up, stalls better. It's a little desirable for sure.
So during this process, the engine mount situation really wasn't a situation. It just was a math equation for you.
Yeah, just pull out a pad and paper. I'm a pad and paper guy.
So then what was the hurdle? Obviously the cowling was a little bit of work to do, but the engine bolted up well, and then all the accessories and the cooling radiator and oil radiators, was that more of a challenge in getting that situated within the cowling, or?
Yes and no. There is quite a deal of room in the engine compartment on a Sonex. I can almost do all the engine maintenance on this engine without pulling this bottom cowl. The engine's just really small in there. So finding a place to put the radiators is a no-brainer. You just slide them all the way back. Finding a place for the exhaust is kind of a no-brainer. You just put them off to the side. You have about 5 inches of clearance in there for an exhaust system. However, a single exhaust system is really hard to fit with this current engine mount. You have to run a dual exhaust system, which I like the dual exhaust. I get compliments all the time on how it sounds. Rotax doesn't want you to have a dual exhaust system for obvious reasons from the mechanical side. But if you properly tune an exhaust, get your pulses right, use your right size tubing, you can produce a good exhaust.
Now, did you fabricate that yourself, or was that like off the shelf and then modified?
I made the whole thing. I ordered all the stainless, just a bunch of 180 degree bends, 90 bends, 45 bends, some straight pieces, a couple mufflers, and tacked them up, and that's it.
So in this exhaust system, is it muffled or is it just straight pipe?
There's mufflers on there. They're small. So this thing, when you're flying in it, it's just got that reverbing wah, but it's just like, do you want a 1969 Dodge Charger with a 440 with dual mufflers on there and keep it quiet? No, you want to go annoy your neighbors.
So you built a bit of a hot rod.
I like hot rods, and I just be loud, be noisy, have fun.
All right, and I'm sure somebody will want to shoot me if I don't cover the inside. So we have to talk about the cockpit for a minute, Casey. And I've seen what you've shared on social. You did your own custom panel, so let's talk about that for a minute.
Yeah, my panel, I just finished it a few months back. I completely redesigned it. The normal Sonex panel is just a flat panel at an angle, and you're really kind of strapped for space. In this instance, I made a triple piece panel, so a 3-piece panel. So on this side of the panel, I have my master, my ignition switches, my V-speeds, approach speeds. I bought these instruments from Canardia Avionics. This is an airspeed indicator, but it also includes my altimeter, vertical speed, and barometric pressure. And they put all your V-speeds in there for you. It's a really cool thing. And I got their Canardia Horus. And the Horus is your 3D, is your EFIS, which obviously has your vertical speed, barometric pressure, all those things. It also has a G meter in there, compass, chronometer, really handy thing. I also put in a MGL V16 radio with a Vega control head. Again, that thing just takes up very little space. The radio is actually underneath my butt, but this is just the control head. And really simple, really intuitive. It's a good radio. And my array of switches: Avionics, radio transponder, position lights, strobes, and fuel pump. And so that piece can be removed. I can service my pitot system and other components back there and put it back into place. My iPad, that's my navigation. So I run iFly. I've used ForeFlight and a lot of that stuff. iFly is personally my favorite. It's just a good old boy GPS. It gets the job done. It's very intuitive. They have 3D EFIS, all sorts of great stuff in there, and that communicates with my ADS-B Echo UAT controller. So I have my ADS-B in and out, and it just transmits it to my iPad. I can remove my iPad dock with 4 screws. There's just nut plates in there. And behind that is my master solenoid, fuse panel, an extra USB array, and I can do any maintenance to the backside of my throttle that I need to do. This is a McFarlane friction veneer throttle, so just push in, push out. If you want advanced throttle, you can twist it in, twist it out. Really nice throttle, really smooth, and just choke. On this side, I have my transponder. It's just an old Becker transponder, 2 1/4, does all the great stuff, mode C. I have my GRT engine information system. Everything is in there you can think of, absolutely everything. It's a small package. It looks retro 80s, but it works. No matter what, it works. I also have my ELT control head here for my 406 ELT. Fuel pressure gauge, my passenger warning, voltmeter, and some extra USBs, and that I can also remove independently as well and service my entire system on that side.
That's awesome. Well, I also wanted to talk about for a minute the common engine in these is in fact a Volkswagen, and the Aero V carburetor and the fuel valve. That basically the sequence is, I think you have to have the engine turning before you turn the fuel valve on. This is not that. So what is your startup procedure, and how do you use or operate the fuel valve with the Rotax?
I don't turn it off. Okay. I never turn it off. In the Rotax fuel system, they really want you to have a return system. So that way, if there's ever any vaporing or anything like that, it can return to the tank. And this one I did make the fuel return system, so I have the one line out to my gasculator to my fuel system, and then after the carburetors I have one return line with a very small orifice in there that just returns any fumes and just a little bit of fuel. The fuel valve never gets turned off, ever, unless I'm doing some servicing to the engine, then I turn it off.
All right, jumping back to the nose of the airplane a minute, we hinted towards it, but didn't actually talk in detail. In order for you to get the power applied to the air and through the air, you have a propeller. What propeller did you choose to use, and how's that working out?
I chose a warp drive propeller. I operate off of dirt and gravel, and I needed something really tough. This thing just bats rocks, and it doesn't care. So in our environment, the warp drive really works best for us. We've used them on tons of other aircraft. This is their tapered tip model with the nickel leading edge. It's a constant speed propeller, so it's a little less tip drag, and you can dial in a little bit more pitch and just really unwind the engine. And I've been beyond satisfied with the prop. It's a great prop.
So obviously it's a 3-blade, but what's the length on it?
The prop is a 64-inch. So that is about the max you're ever going to get on one of these things until you start stretching landing gear. So I already had to put 5x5s on it to lift the nose up a little bit. That's just...
Wait, you had to put... Is that not standard 5x5? Those are like baby tires anyway. What's the standard tire?
Standard tires, it's like a... I don't even remember the standard size, but yes, they're smaller. They're about 1.5 inches skinnier and 1.5 to 2 inches shorter. So,
all right, so a 64-inch 3-blade. How much pitch? It's a ground adjustable. So how much pitch did you put into it?
I probably have about 16 degrees of pitch in there. Yep.
How do you set? Obviously on the ground you set for static. What does your static look like at that setting?
Well, this plane's really interesting because normally you would static at 5,300 RPM, 5,400, and so on climb out you get at least 5,100 RPM. You don't want to load it down too much because you start introducing crankcase fretting or cracking a crankcase. Some of the Stoll guys, they want the full 5,800 on takeoff. This one is just the 5,100 on takeoff. In straight and level flight with a Rotax, they typically want 55, 5,600. So then at full power, you're just able to unwind and utilize the whole 5,500 RPM cruise.
You're able to meet all those targets.
The problem is I exceed in straight and level. I can actually over rev the engine. I get to 5,800 RPM, which is maximum allowable for 5 minutes. But if I pitch it down anymore, then I start introducing load on the crankcase. So it's really at a happy medium right now. It has great get up and go, and it meets my minimums, and I just don't overspeed it. So back off the throttle a little bit.
All right, let's talk about the aesthetics just for a minute, and then in closing, I want to talk about what you do for work. But what did you use to paint this and finish it off?
Well, this plane was, like I said, it was unfinished kit. It had some pieces done, some pieces it didn't. So he had polished some sheets before he was getting ready to put them on, and I didn't want a polished airplane, so I actually scuffed up a lot of the stuff and laid down a black primer first. And then shot my white and then left my black in the scheme that you see, and then just on top of the black I mixed my own paint. It's pearl pigment that I added to a gallon of clear and just shot the clear on over the black, so then you get the purple blue change. So that's it.
Well, came out really nice. It came out very, very nice. Let's roll into your work. How many different is it all like light sport and ultralight? You don't work on any certified? What is the genre?
We work on light sport, experimentals, ultralight, stuff that falls into the light sport category, and we work on certified light sport aircraft. We don't touch general aviation type stuff whatsoever.
Okay.
So,
what's the name of the company again?
Arizona Ultralight Aviation.
In what city?
Tucson.
In Tucson, hot Tucson. Well, guys, I'm really, really impressed with Casey's ability and what he's put together here in this. Obviously, the firewall forward to do that is very difficult. I shied away from that on my own build, wanted to do a Franklin, but between the engine mount, exhaust, and cowling, which you've done all three, it's a tall order. So to have that accomplished and actually function properly is a huge accomplishment.
Yeah, I'm very happy with the airplane. It's worked out to be a really nice and fun toy. It's been a cool experience.
Awesome. Well, I hope to see you putting out some content and sharing your experiences. You've been with this aircraft, with this configuration. Is it 3 times to Oshkosh and back?
In my first configuration once, and this is in this configuration twice. So, yeah.
So proof of concept, everyone. This thing has flown from Arizona to Oshkosh 3 times. And how many hours now?
Oh, this thing I probably have about 375 hours on it from January 2021.
Gaining some hours. Well, thanks for the tour around your aircraft today and sharing a little bit about what you've done.
Thank you, Brian.
Wow, that was a long conversation and not our usual. But I felt there was a lot of value here with what Casey has accomplished and many lessons learned to be shared with our aircraft building community. If you found value here today, leave us a comment below and consider subscribing and becoming a patron to help fuel the truck.